So, good morning, everyone. I think we can start now. We are a bit late already. So, welcome to this third version of this third edition of the Renewable Heating and Cooling Solution Workshop here at Sustainable Places. This is the first time we are, let's say, mainly in presence, even if still the auditorium is not that full, but I hope we'll get more people involved in the coming minutes. So I will be very brief. Many of you already know we organized this first time 2 years ago. The idea was to gather as many projects as possible from European Commission funded projects about renewable heating and cooling solutions in different places. And I would say this year we'll have 14 projects presenting. 10 of them will be here in presence in Nice and 4 connected remotely. And I have the feeling this is really now urgent to discuss about this topic. We know what is happening everywhere. We know that heating and cooling in the end is accounting for most of the consumption in buildings and even in industrial application. So in the end, proving that innovative renewable heating and cooling solution can be feasible and can be applied widely is one of the urgent matters that we need to face in the coming years. And the idea today is since many of the projects were already presented in the past, we wanted to have a bit shorter presentation of each project, but letting more time for us to discuss all together about, let's say, common issues we are facing in these technologies and how we want to overcome this issue, how we want to propose technologies that in the future will be really deployed at market level. So just some information about how the organization of the workshop was prepared. As we did already in the past, since we have too many projects presenting, we try to cluster them in under common topics. So we'll have 4 common topics. The first one will be renewable heating and cooling solutions in industrial applications. We'll have 4 projects presenting here. Then we'll move to high TRL, renewable heating and cooling solution for buildings mainly. Then we'll have the coffee break. And then we'll move to low TRL, renewable heating and cooling technologies, also including thermal energy storage solutions. And here we'll have 5 projects presenting. And then we'll end up with the renewable heating and cooling technologies for nearly zero energy buildings applications. What is important is that we must finish Q2 for organizational issues. And I also ask all the colleagues presenting to keep the time for the presentation maximum 4 minutes. Then we will have at least 20 minutes, half an hour of discussion, like round table. And I really do hope that people attending here in presence and also online on Hopin can interact with us. So anytime you have a question, anytime you have a suggestion about the topic of the discussion, please ask us here, and Valeria is online to gather your request on the chat. So we'll try to discuss as much as possible all the topics. So here we have already 3 colleagues sit down for the first stage for the renewable heating and cooling solution in industries. And we'll have also Dimitris for ship-to-fair connected remotely. So the first speaker is Uli Jakub, who is going to present HyCool project. Then we'll move with Dimitris. I won't come back to the stage, so you will see the next one will be ship-to-fair, then friendship, and the last one will be Asta presenting the slides. So please, Uli.
Yeah, thanks, Andrea. Good morning, everybody. My name is Uli Jacob. I'm from the company GR. I'm one of the project partners of the HyCool project, which is a project which is now running since 2018. We are looking into industry applications, especially to use solar heat from Fresnel collectors, and there also to run adsorption chillers and hybrid chillers. And therefore, I just want to present to you our latest results of that project, because the project ends now end of October this year. And with that, it's now time really to present some of the final results which are available today. The mission here is really to have an idea what is the the advantage to use Fresnel collectors, concentrating collectors, which deliver higher temperatures up to 170, 180 degrees, and to couple that also with cooling issues or with cooling solutions in that way, with hybrid heat pumps to deliver heat and cold to industry applications. Yeah, in that project we have 2 pilot sites. Both are located in Spain, in the region of Barcelona. One is a factory which is producing pre-cooked fresh dishes, and the other one is a producer of flavors, and both have needs in cooling but also on the hot water side and steam side. We have their installations, 2 installations finalized with Fresnel collectors at the both factory. So this one, which is looking at this pre-cooking of dishes, in total 360 square meters Fresnel collector installation, and the other one are 800. On the right-hand side, you can see 2 pictures. The top one is the Bordeaux factory, where we have a rooftop installation, and the other one is the Givedo factory site, where it's installation on the ground. In both installations, we deliver high temperatures to the system, especially also to run the hybrid systems, so which means the hybrid heat pumps. Those heat pumps can deliver different temperature levels for industrial cooling applications again. So we're talking here temperatures of +5 degrees, but also -10 degrees. So depending on the different needs. And in both installations, we have such hybrid systems, but with 2 different configurations. So a cascaded one and another one which is in series. More details on that can be explained, of course, further on in the breaks. So I will not bore you with more details here. But what I want to mention also is that we have also tried to get involved to use phase change materials for different kind of storages, especially at that high temperatures from the system. At the end, what's important here in the project is that with all the information, with all the experience we've collected during that time now in the project, we have also started a Zen workshop agreement, especially on our hybrid heat pumps, trying to get together somehow information which then can end up later on into the standard, how to calculate these hybrid heat pumps. And there's to mention that this document will be available end of this year, so probably in November already, and it will be free of access. So if someone is interested to get known what is written down there, then of course you are able to check that. And the other thing is that we have a consultation phase running. So if someone is interested, then please join our website. There you get a direct link to download this draft already, to get known what is written down in this pre-standard. Finally, just to mention, also e-learning tool is now online, especially trying to explain the different technologies. And if someone is interested to know more about the high-cool technologies, then please just visit our website or get in contact with us. And I'm happy to start also the discussion later on different questions from your side. So thanks.
So good morning from my side. Can you hear me? Hello, can you hear me?
Yes.
Excellent. Sorry for this. So this is Dimitri Georgiou. I will present today SIP2FAIR project. I don't see the right slide. Now it's okay. I represent TVP Solar, who is partner and technology provider in SIP2FAIR. Our project is targeting at agro-food industries, and the scope of the project is actually to show the potential of industrial solar thermal applications. Next slide, please. Good, thank you. So the project SIP2FAIR started back in 2018, on April 2018, and it will last more than 5 years to implement a set of demonstrations, 4 demonstration sites, and develop and demonstrate 2 digital tools. One called replication tool, which is about focusing on the feasibility of solar thermal applications. It helps users to pre-assess the potential of solar thermal in their sites, in their thermal energy processes. And the second tool, the control tool, aims at optimizing the operation of the solar thermal systems through basic and advanced control strategies, including including the incorporation of weather forecasting for the next day, forecasting of solar heat generation. There are 15 partners in the project, including 2 solar thermal technology providers, TVP, which we have developed and produce our high vacuum flat panel technology, and Industrial Solar, which focuses on linear Fresnel technology. As you can see, we are aiming to decarbonize processes of the user partners through these demonstration sites. It is really important that the project has moved to the actual operation of the solar thermal systems. And in the next slide, you can see, please, can you, 2 of the demo sites, which TVP has installed its panels. One is located in the southwestern France, and it's a meat processing plant, Larnaudy, where we have installed a 1 megawatt capacity solar system with dual use. One subsystem will preheat the water for the boiler, and the second will actually produce low temperature hot water for direct process integration. What is interesting in this site is that the company has decided and is investing on the installation of industrial heat pump plus additional storage tanks so that they can decarbonize fully their processes. This integration will be performed as a next step in hopefully early 2023. The second site is Martigny and Rossi in the north part of Italy with 600 square meter solar system, which has this interesting also application of dual mode operation. During the summer period, we produce steam, low pressure steam, whereas during the winter period, we produce hot water for space heating. Next slide, please. I see that my time is running. So these are the important, let's say, conclusions, lessons learned from our side concerning the barriers, the challenges, and the opportunities for solar heat for industrial processes. First of all, the barriers. We know this is kind of a fact that the priority now of the European policymakers is on actual electrification, so renewable electricity. Renewable heat is lagging behind, and we need to see similar tools that are applied, financial tools, for instance, that are applied for PV, for instance, could apply as well in solar heat. Another regulatory barrier is about the actual fragmentation of the regulatory landscape in the different countries, but within the same country in different regions. And as the SIP market is not developed yet, there is a lack of awareness on the actual regulatory authorities at local and regional level. User acceptance is one of the major challenges. Industrial users are not aware about the potential of solar heat. And from our side, we need to inform them, persuade them of the value of solar heat, and then implement at small scale at first and then at larger scale. Another major challenge is the integration into the existing thermal processes and thermal systems. You know well that most of the industrial companies use fuel-driven powered boilers and network of steam network to feed heat to their thermal processes. And this integration with solar thermal needs to address a set of technical and operational challenges to make it operate smoothly. And of course, there are major opportunities for solar heat driven by the existing high prices of energy, but also on new financing schemes and incentives for renewable energy and renewable heat more specifically. And of course, the market potential is mostly untapped. One could claim that the market for industrial applications of solar heat is almost negligible. So there is a major potential for this, and companies have turned their attention to solar heat lately, not only because of the rising prices of energy, but also due to the priority in their agenda for decarbonizing by 2030 partially and 2050 fully. So this is from my side, and we can continue to the next project. Thank you.
Okay, thank you, Guglielmo. So my name is Valérie Riem from CEA. I'm the project coordinator of the Friendship Project. This project has been founded by Europe on a call dedicated to solar heat for an industrial processes in a range of temperatures that is the mid-range temperature, so temperatures from 150 to 300 degrees Celsius, though higher temperatures than in the Friendship in the Ship to Fair project that Guglielmo presented just before me. The project involved a mix of RTOs and industrial as well as consultants. So in the partner from the industry, we have Absolicon and Industrial Solar, who are the key partners because they are already selling solar technology like small parabolic soil collectors and linear Fresnel collectors. And we are also we have Clariant, which is a big company in the chemical industry, and Sonae. Both are a lot of processes in this temperature range that of interest for this project. So in the project, we are not only working on delivering heat at high temperature from the solar collectors, but we are providing system rather that can, from this solar heat or from the heat from the network on site, deliver also cold from positive cold to negative cold up to minus 30 degrees Celsius. And we are also providing a way to store energy directly on the site from the solar, but also from the site. So two two different kind, let's say, of system are developed. The first one is a ship 200, so meaning it is more appropriate to be used for processes where heat is needed up to 200 degrees Celsius, and the ship 200 is more for the processes with higher temperature, so up to 300 degrees Celsius. For both systems, there will be a validation. The first one will be the ship 200 that will be validated at the end of the project in Grenoble, in France. So the ship 200 overall system, and the ship 300 system will be only numerically validated. Well, so no real plant for this option. So what we really work on during the project, so on the collector side, we have a nice work with Absolicon in order to upgrade the capacity of their existing collectors. So this task is over now with good results on selective coatings. So on the one other important point is the work on the heat pump. So this is led by Sintef. So the status actually is that they are in the phase of nearly commissioning the loop where the new compressor will be tested. So compressor with capacity to go to higher temperature. The first steps now is trying to go to 180 degrees Celsius as a first step. The 250 is on the long term, so it was just paper study at the end. The work on storage is interesting, as the storage is a key equipment of the system, because this will be the interface with the process, and the capacity of the storage will be to store the heat from the solar collectors, but also, if needed, for the surplus of heat from the existing heating network going to the industrial site. So we are near to the commissioning of this equipment. It will be tested first alone in Grenoble, and then will be included in the final demonstration of the whole system. And finally, one last part is dedicated to the chiller. So we have done work on the ejectors, chillers, and absorption chillers. Paperwork on ejectors, but on the absorption side, we commissioned a demo of the absorption chiller. This will also be tested as a unit in CA at INES, and then be included in the final demonstration of the system in Grenoble. So a few points on the right-hand side. So the interface is the storage capacity, which is probably interesting for the sites where they can see a need for store energy and they don't have even a storage yet. We are providing heat and cooling, which is important, because if you look to the industry, there is many sites where they need both. So it's important to provide both. And important thing also is, as we work on systems, we saw that with the input from our end users, it is important also to be very scalable, not only in the scale of the system, but also, and if they don't want to have cold or a specific storage able to store from the solar or from the site, you can even change the system to provide what the end user need. And that's all for me. So.
Hello, good morning to everyone. My name is Juan Enriquez. I'm the CEO of an SME engineering company based in Madrid. I'm representing the ASTEP project that it's a sister project of the last presentation project. This ASTEP is the acronym of Application of Solar Thermal Energy to Processes. It's a 48-month project. It was started in May 2020, and we are about to run a little bit over mid of the project. The idea that the two main innovations of this European project is the innovative solar collector and the thermal energy storage to store part of the heat that is being produced by the solar collector. We are 13 partners. We are covering both academia, RTOs, SMEs, and industrial partners, especially the industrial partners are related to the industrial case studies. There are two case studies, one in Greece, in Corinth. It's a dairy production plant. And then the second one is this dairy factory has requirements for cooling and heating. And then the second one is a steel factory in Iași, in Romania, and they have higher temperature requirements for the coatings of the pipes. Basically, in this part, okay, the main two aspects, as I mentioned earlier, is the solar collector and the thermal energy storage. So we have been doing, this solar collector is based on two patents from University Polytechnic of Madrid and UNED. And these two groups within these Spanish universities, they have a long experience in the area of solar energy systems because of many national and international projects. And then they develop, this is the solar collector, it's called Sundial. And this is the image here is the one that is being developed previously. The main innovation for this project is that this solar collector will have two different versions depending on the application. Okay, as you know, depending on the irradiance of the locations, we are taking advantage of having a simpler solar collector for lower or southern locations, and then we have a two-axis track device, sundial, for the higher or northern locations. This way, we can increase the number of hours of application of the solar collector, even during winter time. And then that's the major innovation. The second major innovation within the project is the phase change material that is being developed to store part of the heat. This is underdeveloped by the Wrocław Technical University in Poland, the University Polytechnica of Cartagena in Spain, and us. Basically, in both of the projects, we have been involved in the CFD modeling and optimization of both parts. And then, above all, we have an innovative control system to control both of the devices and put it together with the system control or cooling system of the two case studies. And this is developed by the company Iris in Spain. Okay, so this is what I just mentioned earlier. There are two major challenges. For the one in Corinth, in Greece, they have needs or requirements related to cooling and heating. As you could see in the temperature, we need a high temperature for the pasteurization of the milk, but at the same time, we need some cooling requirements for the storage of the milk and the processes and the products. And then we are using this as we in this southern location, as I mentioned earlier, we have a lot more hours of sun during the year. So this sundial, as you could see here in the image on the left, it's it just moves on one axis, and then we save a lot of money in terms of the control and in the construction of the device. And then in the second case, for the one in Yasi, even though it's only heating, we have the challenge that is quite north location, is closer to Poland and to the Ukrainian border, so it's very high north. And then this time we'll be using this sundial collector. It's a little bit different. It has is able to move in two axes, so it takes advantage of most of the hours. So and then and the main challenges outside of the project, outside of the technical side, is the increment of the prices of the raw materials that I guess that everyone is facing right now in Europe and in the world, and then the logistics. We started the project during the pandemic. We didn't really, things were delayed, but as we were in the beginning, most part was done in the laboratory, so we didn't really have too much or too many problems related to that. But now we are facing the problems of the increment of prices. So that's bad because, as you know, the budgets are tight and they cannot be extended. So we are facing problems with the raw materials and the logistics. Okay, so in this part of the patents, the communications, this project, it's based on these 4 Spanish and international patents. We are, additionally, we have a pending patent related to the thermal energy storage. It's been led by Wrocław University, and it's included UNED, ADSC, and UPCT within the patent. We are very involved in the presentation and the communication. We have been attending different conferences, and we have presented many papers, especially in solar paths. And then we have a few more papers under development for this project. I think that's all.
So thank you. We were a bit late, so I guess we can save 10 to 15 minutes for the discussion. So as you know, we decided to plan some starting topic of discussion, but of course it's open to all of us. Okay, we have already a question. Okay.
Hello. The temperatures at the moment that we are using, they could go until 224 degrees. That it's supposed to be, because those are the trials that we have in the experiments that we have been developing. We tried different. In the presentation, I saw some public images of the internal of the thermal energy storage, and then the maximum temperature was 24, I think 24, 20, 30, or to 30 degrees.
Okay, thank you. Any other question from the chat? Okay. So coming to our common discussion. So the first one, I think already Dimitris, especially for ship to fair, already presented many challenges, opportunities, and so on. And the point is, which are, in your opinion, the main challenges and opportunities for renewable heating and cooling solution in industrial applications? So which technology you see more relevant to be developed, if it is still in the low tier range, or which one is already on the market and ready to be, widely deployed across Europe?
Hello. Hello? Yeah. Just a short answer on our side. So we have an end user in the project, and we try to design our system for different sites of our end users. And what you show, it's the main challenge is on each site is they are missing land and space to install, especially solar fields. But not only, even in the case of large heat pumps or equipment, it's a problem too. So this is, for me, the main issue. If you want to get on site to install something that is large, there is no place in Europe, let's say.
Yeah, maybe I just say some more words on that. Of course, that's the same experience in our project, the HyCool project, that if you go to a site, in factory site, that usually you have not enough space. That's one thing. The other thing is really to think about the implementation, really, how and which stage and which point you can really feed in your solar heat in an existing system, and especially also with the storage issues and so on. So that's really one of the main challenges. And if you think you have to also to control the system, so the system itself, it's not a problem at all. But to do that in the overall picture with the existing processes, then you get at a point where just the implementation is a different issue. And those are the things which I think, especially because you have asked about TRL, so the technology itself, the single components, they are already on a higher level, of course, yeah, but the systems and the implementation is still some path to go, really to get it as a market-ready product at the end. And also the collection of data from the different demonstration sites with the different applications, that's also something which is missing and which is, I think, necessary really to look into in the next years as well, to push this kind of renewables, especially to decarbonize the industry.
Well, I think we are sharing the same or facing the same problems. For the companies, they have limited space, and usually the problems that is either you can try to install the equipment on the ground, or because of the weight, it's difficult to install it on the roofs. So usually the companies or facility factory don't have so much space on the ground, so you have to try to install it in the roofs, but that requires, because of the heavy weights, especially because of this, we are facing that problem specifically in one of the sites. We have to make some reinforcements in the roofs to support the extra weight, and that's not supposed to be. We didn't really allow that, or we didn't think so much about that. So that's one of the problems. But the major issue here that we are facing is the rise of the prices of the raw materials, especially things that they used to be cost 100 euros, now they are 300 euros. So we are facing really important problems, and the delay of many parts. And additionally, because of the pandemic, companies have or went bankrupt, and so that was a problem because of some of the potential equipment that we were supposed to purchase we have to change it in the last minute because that company that was supposed to provide the equipment went bankrupt. So we have to change completely the concept in the meantime.
Thank you. Dimiris, do you want to add something?
Well, yes, I would like to distinguish, let's say, the challenge of limited space at the short run and the long run. So definitely from the long run, this is a challenge, because if we are to go for almost 100% decarbonization of industrial heat, the lack of space either on the rooftop or on the ground is a major challenge. However, in the short term, where, as I mentioned, there is no actually no established market of solar heat for industrial processes, I think that even a small space is available in almost all industrial sites on the rooftops with some reinforcement could help the industry to become more familiarized with this type of applications, especially as far as their integration to their existing thermal systems is concerned. So this is, I think, important to start rolling out the demonstration sites, not only demonstration sites and larger ones, in those sites that there is even a small space, but of course to sites that there is much larger space. I'm aware of several cases where space is not an issue, but of course there are the large majority have space limitations.
Okay, thank you. I have a question linked to the comment made by sorry.
Yes, good question. So I will not answer on what we will be able to realize on the demonstration at SINTEF, but what is expected is a temperature outlet of the collectors, solar collectors, for about 160 degrees Celsius in let's say medium temperature, and then the outlet of the heat pump is expected, well, on the short term at 180, and on longer term 200. So the lift is 20 and 40, but it's still to be demonstrated. Okay.
Just briefly to Uli, but to all of you. I mean, you mentioned that most of the technologies themselves, they are already ready to be deployed on the market. Just briefly, this question, then we move on.
Andrea, just one remark. I cannot hear the questions from the audience. So if you can repeat them, it would be great.
Yeah. Okay. Sorry. The question before was about the temperature lift on the heat pump that is developed by Friendship Project. My question is, we have technologies that are closer to the market as a single technology, while we need to prove that the system can be, in the end, reliable and widely applied. Should we wait for more European-funded project to prove this ability to come to the real field, or should we force, for example, policymakers to release incentives to industries to, provide themselves, so to be the actors of pushing this forward?
Yeah, all right. So somehow, two answers. First of all, more European-funded projects in that way are, from a perspective of a research organization, fine, of course. But I think what's more important is that policy is really pushing this kind of technologies into funding schemes. And for example, in Germany, we have already such funding schemes, especially for solar process heat, where you get 50% of your investment costs directly funded. So if a German company wants to install such systems, it's already somehow attractive. But I think European-wide, that should be much more in that way to get some funding schemes available, and that should be stimulating really the market uptake somehow. As the colleague from TVP was saying, there's no market so far. So I think that's the most crucial point, really, to push these technologies also in combination with heat pumps. On the other hand, I think there's still some work to do, especially on the systems where research is still, or should still ongoing in the different calls from the European Commission.
Yeah, hello, Manuel Salensek from Steinbeis Europazentrum in Germany. Thank you very much for the interesting presentations. I have one question regarding competition with photovoltaic systems, since you also mentioned that area is limiting factor. So can you comment on in which cases solar thermal energy has an advantage over photovoltaic systems, or how you can compare both systems?
Yeah, I will give you a short answer. Probably the colleague remote will start.
Okay, so yeah, there is competition in terms of land availability, if there is a limitation on this. Solar heat would definitely be preferable in the cases where there is a need for heat at the temperature that the solar technology can deliver, simply because the solar to heat conversion efficiency, it's much higher. It's almost 3 times higher compared to photovoltaics. So in that case, where there is a constant need for solar heat at the vicinity, then solar thermal is preferable compared to photovoltaics. If there is no heat demand in the vicinity, then of course photovoltaics is a solution, because heat is not easily transferred along a relatively larger distance.
Yeah, maybe I can just add something to that. The point is more from my point of view that you have to check whether what kind of energies are already installed in the factory side. So what kind of needs are there? Is there a huge need on electricity, but also in steam, whatever? Usually you find steam networks and these installations, and to produce steam with photovoltaics, that's somehow boring. You need a special heat pump. We have talked about it, high temperatures to really reach that. On the other hand, solar thermal collectors, especially concentrating collectors, can easily deliver this kind of temperature levels for existing steam networks. The point is the industry changing their way how to deliver energy inside the factories? Is it still only steam networks usually, which you can find worldwide, or they probably turn that also to low greater temperature levels to other kind of distribution networks within the factory site? And then I think then especially photovoltaics with a usual heat pump with 50 to 80 degrees Celsius will be the most competitive technology against solar thermal. But nowadays usually you have steam networks, and there I do not see this kind of competition for that application. If you think about cooling, which is, I think, in most of the projects here also there, then of course it's a different issue in that way that if you compare or if you combine the photovoltaics with a conventional compressor chiller, then of course it's from a CO2 point of view much better than probably to run a thermally driven chiller. So, but that depends at the end on the overall cooling demand side and also the heat and the dedicated factory side.
One just remark from my side concerning industrial heat application is that heat pumps require not only electricity but also a heat source. So, and they have some limitations in terms of temperature lift. So in industrial applications, solar thermal will be needed. So in the future, what I see at least is the use of heat pumps, of course, together with photovoltaics, which can be installed not in the vicinity, but somewhere else, so it can be provided by the grid, whereas solar heat could be produced on site with this much higher efficiency I mentioned before. And of course, storage, thermal storage is part of the equation if we have to go to 100% decarbonization, both short-term and seasonal storage.
Thank you. I'm sorry we are running out of time. So
Thank you.
Yeah, just one last comment from Valerie. I don't know if John wants to add something, and then we move to the next one.
I wanted to comment the previous question about the implementation. What it's really important. Yes, we need more fundings from European Union for pursue the research. But today there is a lot of technology available, reliable in the solar heating and cooling for solar heating and cooling application. So we need policies for sure, because there is a lot to do today, and we need to make it real today, not in 5 or 6 years. So funding is okay, but now we have to act very quickly. So this is a message.
So thank you all again for the nice discussion, and let's hope to meet next year again.
Thank you.
So we are ready to go for the next session, which is ITRL technologies for buildings application. So we have here Marco and Serena, and Sables is remotely connected. The first one will be GeoFit. Just one remark I forgot to mention. For the attendees here, we have some envelopes there collecting some of the brochures and leaflets of the project. So if you want to bring one of them before leaving, just do it. So, Marco, please.
Good morning. Marco Calderoni. I'm from R2M Solution, and I am the coordinator of the GeoFit project, which is about renovating buildings with geothermal. Okay, great. Very briefly, it's a 4-year project. Meanwhile, 4.5, roughly 10 million budget, and 24 partners. And the project is mainly about 3 levels when it comes to the technology, let's say, so the ground source heat exchangers, heat pumps, and emission systems. And when it comes to the process, it embraces, say, the design, the installation, and the operation. So it's quite comprehensive, therefore also quite complex. We have 5 pilots, none of them fully operating yet, but we'll make it. Now, I would like to focus a little bit on single technologies, and in the last 2 slides on the main results. So technologies here, I just put some pictures. You see on the top left, you see one of the 3 types of heat exchangers we're trying. These are earth baskets, quite uncommon. Then you see in clockwise sense, you see the 2 kinds of heat pumps we're testing, one being an electric heat pump with a medium-low global warming potential, and the other one being a hybrid heat pump, meaning absorption plus compression. Then you see an innovative underfloor heating system provided by partner Uponor. This is already commercial, by the way. Then you see drones, where we tested the application of drones to checking the thermal stability of the envelope of a building after drilling happened, because drilling causes some vibrations. Then you see a ground penetrating radar. This is to detect underground utilities, if any, before drilling starts, this being one of the risks one encounters when drilling. And then bottom right, you can see the application of another kind of radar to building stability. Again, because while drilling, you have the generation of vibrations which may harm the building. So these are most of the technologies, not all of those we are testing. You see, it's really cross-cutting. So we have to do with a lot of technologies. This is one of the main complexities of the project, but also one of the main, let's say, fascinating sides, I think, of it. Okay, and now let's talk a little bit about findings, because the project is about to end. We will finish on the 31st of October. First of all, some quantitative results. A reduction of 50 to 60% in primary energy consumption compared to values before retrofitting, of course. Using electric heat pumps is possible. This was one of our KPIs, and we are more or less there. This is good. When using hybrid heat pumps, so basically sorption-based heat pumps, we can reduce the primary energy consumption by a factor of, by a percentage of about 25 to 30%. Thanks to the use of low temperature heating, underfloor heating, floor ceiling heating whatsoever, we are demonstrating that the COP of electric driven heat pump can be increased by approximately 15 to 20%. When it comes to running costs, we are seeing that those can be reduced by approximately 30%. Of course, this depends very much on the local energy prices, and this will be changing in the coming months and years, but that's where we are now. And then we come to the critical point of drilling cost. Those being in this very moment, I'm only 4 minutes, one of the main issues. So you see for 11 boreholes, 100 meters each deep, we paid in Sant Cugat some 60 to 70 Ks, which is a lot. And below you see for the horizontal excavation. But of course, this is also the cost item which has major or higher margins for reduction. I need to rush, so qualitatively speaking, authorizations depend on the country. It is difficult to provide a general answer to the question which authorizations are needed, but with closed loops, usually we don't have issues. Geothermal is complex because of the many technologies needed. You need some kind of interdisciplinary team, design team. Low GVP is an issue because manufacturers have to reduce the global warming potential. Fortunately, we're seeing that many or some refrigerants with medium or low GVP do not harm the COP of the heat pumps. This is good news. And very important, if you are about to refurbish your house, renovate your house with radiators, keeping those radiators, then it is possible to go geothermal with some attention, for example, using a high temperature heat pump, which provides heat at, let's say, 55 to 60 degrees, insulating the building and optimizing the flow rates. And finally, with geothermal, you have the risk of freezing the ground in the long run because you're constantly extracting heat from the ground. In order to avoid it, this happens in the long run. You can increase the size of the ground source heat exchangers, increasing the cost, of course, but hereby you extract less cost per unit of space, less heat, sorry, for unit of space. You may consider to inject heat in summer, so using the ground for passive or active cooling, thereby increasing again the temperature of the ground. And finally, you may consider using an additional heat source, air, for example, as is happening in the Galway pilot in Ireland, when the air temperature is high enough. And last but not least, underground utilities can be detected with quite a good, let's say, security using ground penetrating radars. And that's it. Sorry, I was really too long. Next speaker.
Good morning, everyone. I'm Serena Scotton. I'm working as a project manager at RINA Consulting. RINA is also the project coordinator of the Sun Horizon project. And I'm quite new in this position since I've been the coordinator for only a few weeks now. So Sun Horizon is an Horizon 2020 project. It started in October 2018. It was supposed to actually end in September 2022, but we had, as other projects had, some delays during the pandemic. So actually we got an extension of 12 months. So the project will end in September 2023. Sorry. So Sun Horizon aims at demonstrate up to TRL 7 technologies, more specifically sun-coupled innovative heat pumps. We are installing these technologies in residential and tertiary buildings in 7 demo sites all around Europe. We will go more into details later. In this project, we are coupling the different technologies in 5 technology packages, and we aim at covering at least the 80% of the heating and cooling needs for refurbished and new single, multiple family house and tertiary buildings. Apart from this, the goal of the project is to reduce the Sun Horizon heating cooling technologies CapEx and OpEx. We want to, of course, replicate the concepts furthermore in the next years in other countries. And we also aim at promoting the cloud-based functionally monitoring in Sun Horizon. So a quick overview about the consortium. So we are 21 partners from all around Europe. It is an industry-driven consortium because we have 12 industry partners, 5 from large enterprises, 7 from SMEs. Then we have 5 academies and 4 associations and stakeholders involved. As I mentioned before, the project is structured in 5 technology packages, which are combining the technologies involved within the project. Here in this slide, you have an overview. So we have 3 different kind of heat pumps provided within the project, so from Fahrenheit, BDR Therme and Boost Heat. We are using solar thermal panels. We are using thermal storage, certified thermal storage, and we are providing in all demo sites space cooling, space heating, and domestic hot waters. All these technologies are, let's say, controlled by a monitoring platform, the Sun Horizon app. As I was saying, these 5 technologies packages are installed and applied in the 7 demos we have in Europe. Here is a quick overview. So our demos that are located in Germany, Spain, Latvia, Romania, comprehends social housing apartments, single family houses, civic center, huge university dormitory. So we have really very different pilot cases. And I think that's it. I kept it short with the timing, yes.
Thank you. Zabol, the floor is yours. One of the main issue we are facing, I'm involved in many of these projects, so I know which are the lessons learned so far from the demo site installations. So, I mean, do you see the design phase as a bottleneck, or the regulatory, which is of course different in any country and so on, or anything else that is somehow limiting the efficiency of the implementation that we tried in the project?
So in the GeoFit project, the answer is very clear. The main problem was the design. And I think this is particularly true because GeoFit, as I said during my presentation, embraces main technologies. Geothermal is really multidisciplinary. Thermal engineers do usually not have experience with underground, with geological stuff. And all the issues we are facing in the installation phase were born in the design phase. So for me, the answer is the design phase. And then, of course, like in any research project, the cost. And as I said, I am sure that the main area for cost reduction in geothermal projects is and will be the cost of drilling. So this is, let's say, and this is really technological. The main problem is that there are only few companies, really few companies, which do that, especially for shallow geothermal, so down to 100, 120 meters. We're not talking of kilometers, you know. And so very few companies with limited experience. So there will be a great potential with the learning curve, I'm pretty sure.
Yes, regarding Sun Horizon, one of the biggest challenges that as I said, we have 5 different technology packages. So we have really a lot of several combinations of different technologies. So it is really important in the design phase that all the technology providers really cooperate and take the decision together, thus to avoid having issues when we go to the installation phase. Then another obstacle that for sure created some delays in Sun Horizon was finding well-formed trained installers. So this is an issue we had. And so one of the solution we came up with is that for sure we need to, when we interface with the installers, the technology providers, were actually having some dedicated training on how to instruct installers to install and treat the technologies. And also a good solution would be also to beforehand preparing some videos with dedicated material for installers.
Thank you. Any question from the audience? No. Another point is that since these were ITRL projects, so let's say close to the market, how did you engage, the local stakeholders, like the owners of the buildings or the partners involved on site? Did you interact with them? How were they behaving? If they were, let's say, part of the consortium or outside the consortium, did you see any difference or a way to overcome barriers?
Well, engagement of local stakeholders, of course, is a challenge in research projects because you have a few stakeholders on site. But this, I think, was, at least in GeoFit, was one of the added value of the project. So we do have technology providers within the consortium, such as Uponor for the emission systems, Oxner and Fahrenheit for the heat pumps, and so on. But they mainly, or to a good extent, activated local companies to either their commercial branches or other companies which resell those their products or reinstallers. And this, I think, is again one of the main added value of such a high TRL project with many pilots, that you are somehow triggering a market, because and this is capacity building, but it's capacity building based on real experience with all the mistakes that those people make and can make during installation of something they're not very familiar with. But then you have, especially when it comes to drilling, but then you have, let's say, some pilot projects and companies, like installing companies, who have made a small experience, but quite deep, because there was a lot of know-how around them, and may want to sell again the same project. This is at least what we hope. But to some extent, I'm sure this is happening already. For example, and then I'm leaving the floor to you, we did realize that in Ireland, where we do have 2 pilot projects out of our 5, there is basically no company or almost no company capable of drilling at shallow level. And those who offered were extremely expensive. And this was let's say, the sign for our drilling partner from Spain to say, okay, interesting. Ireland is a good market because costs are far higher than in Spain. We want to go there and start making projects there. And Catalana de Perforaciones will likely lead to decreasing the cost of drilling in Ireland, because the others will have to adapt. And well, this is the way we're triggering a little bit the market of drilling in Ireland.
Well, regarding Sun Horizon and the relations with the local stakeholders and end users, I think we're managed quite well. Our demo managers were really quite in contact with the end users and local stakeholders. We saw a little bit of difference if we compare some demos. So for instance, the 2 single-family houses in Latvia compared to some demos in Spain, Germany. Also because if you look at the data, so for instance, the heat pump market are very much deployed. So there are huge markets in Spain and Germany, while in Latvia is not that extended yet. So a bit of maybe reluctances at the beginning in adopting, switching from gas boilers to heat pumps. But once they joined the consortium, they received all the information about the project, and really they really have to thank RTU, our partner, for the good relationship. So I think we managed to really get all the stakeholders and end users on board within the project. And of course, key aspect is really to, frankly, really speak and talk with them and explaining all the details, all since the first stage of this project, about the benefits and also about the technologies, how they work, how much space also they will occupy, in the building. Because if you're living in an apartment, you also want to know if you're switching from a gas boilers to our package, and to really have a clear idea of what you're going through. But yeah, we have positive feedback on that so far.
Okay, thank you. Kian.
Thanks, Kian from Uponor. Actually, we're a partner of GeoFit. I want to learn something from Sun Horizon project, because you have 7 pilots, and I'm still struggling with 1 pilot. So it's quite an amazing achievement you can achieve for 7 pilots. So from GeoFit experiences, when it comes to the whole system and implementation, we faced a lot of challenges, especially on top of what Marco just said, also the integration part of different suppliers and different partners, and the product, of course. So because we need to integrate different solutions into one pilot, and the engineering part has been quite challenging for us. And so the first question is how, because I understand you have different packages of solutions for different building types in different climate. How did you achieve this complicated engineering side? And the second question is that in GeoFit, for example, we have a lot of problems with good control and data management, because different manufacturers have their different protocols. This means that some will push all the data into BMS system, or some is locally stored. I see that you have some cloud functionalities for the data pipeline management. How do you manage data from different protocols and manufacturers and give good, say, validation result for these 7 pilots?
Okay, thank you for your questions. I'm not sure I can fully reply to all of them, because for sure, I think I still have some gap at the second question, since, as I said, I'm still onboarding as coordinator. Regarding the first question, however, it was about the demos, how we integrated on the engineering. So what I can tell you is that it was a long process. The project is not perfect. We also asked 1 year of extension, so it took a lot of time, all the design and engineering phase. From the lesson learned, indeed, I also mentioned that all the technology providers must really cooperate and sit on the table during the design phase. I think some of the technology package we have worked better than others, so they cooperated a bit better. But as a lesson learned, and yes, from next experience, next project is really to have some dedicated workshops and meetings among technology providers, because it is really complicated. And then if you don't have a real pictures, then when you go to the installation phases, it can be a disaster and create huge delays. Regarding the data, we are still optimizing the platform. We are collecting data from sensors that are installed provided by Schneider Electric. Then we have IS working on collecting, treating data. And I do not recall, sorry, your full question about the monitoring. Okay, so on how, okay, on different communication, on that, I cannot answer you right now, so I don't have the correct, so maybe we can keep in touch and exchange emails, and then I can come back with a more precise.
I may compliment you, Serena, because TVP is also participating in Sun Horizon, and we have experienced these challenges that have been mentioned. It is true that data collection, transmission, sharing is not trivial, but there are several alternative solutions. Typically, some of the technology providers, if not all, they use PLC, so data are collected through the PLC, and through BMS or other solutions, they can be set at the cloud level. What I could say from our own experience is that it's really important that the local user is really committed, and some local engineering company or engineering competencies, if not available within the user partner, should be involved so that the integration of the different technologies is performed smoothly with the support of course, of the technology providers.
Okay, thank you, Dimitris, for the clarification also from your side. I don't know if Marco.
Yeah, I just wanted to stress what Kian from Uponor just said. The data communication issue is really a problem, and what surprised me even more is the fact that despite the high level of know-how in research projects around the table in GeoFit, we are still struggling with collecting monitoring data. And this is also because of the protocols of the different equipment, pieces of equipment. But this is really a big problem because you have these pilots which are crucial and central in the project. You usually come late with a operation, and then you think, okay, now I'm there. Now we're starting to collect data. No. Then it takes months and months to, not always, at least this happened in GeoFit, and I was really surprised about that. I thought, meanwhile, after FP5, FP6, FP7, Horizon 2020, Horizon Europe, we're there. No, that's not yet true. So the monitoring issue and the communication issue are really big issues, which often are neglected because one thinks or at least we researchers focus on the technology, on the thermodynamic cycle, stuff like that, but then come a huge ICT problem, which still needs to be solved, I think, to be made easy.
Thank you.
Sorry. Can I contribute to this? I don't know if
if you unmuted, I will suggest, because we are just on coffee break time and I want to leave the floor to Maria for one last question. Maybe you can give your presentation at the beginning of the next session. So you will join the low one if it's fine for you. At least you can.
I wanted to contribute to this question, if it's possible.
You are still muted, Daniel.
Okay, I agree that the data monitoring and data collection is very important. For example, in our—
Thank you very much, Andrea, and thank you very much also for the very useful presentations. I come from the side of projects where we prefabricate components that are installed on the building, and they are hybrid components that include both passive and active systems. Excuse me. So to start with, I fully agree with you for the discussion for the data storage and handling of monetary data. But I wanted to ask you two questions. First of all, in your projects, and more specifically in the pilots, do you ensure or do you account for the minimization of losses through the envelope before proceeding to the design and dimensioning of the active systems, whatever this is? And the second question deals with a problem which I believe it's common to all our type of projects, is the post-project servicing, monitoring, data handling, and user engagement, which I think are very crucial problems to validate and prove the viability of the technologies.
So the question is how we engage users. Is this what you're asking?
The post-project phase, let's say. How you manage the acquisition and data treatment, how the users are engaged after the project is ended.
And by users, you mean the pilot owners, let's say, the people living in the...
Yeah.
Okay.
Quite brief, because we have already a coffee break time. Huh?
Okay, so very quickly, first question, yes, all the pilots have been pilot buildings have been insulated either before, so they were already insulated when the project started, or during the project with money from the European Commission, except for one, because this is in Galway, Ireland. We do have a swimming pool, and then the swimming pool is a completely different story. The geothermal system is heating the water of the swimming pool, but all the other 4 pilots have been insulated. Engaging end users, well, most of the pilots belong to universities or research centers. So, of course, the people using the pilots, living in the pilots, are researchers themselves and are involved in the process of monitoring, etc. In the residential pilot on the Aran Islands, that's completely different. This is a family. They have been sent out for 2 weeks to replace the floor with the underfloor system. And in that case, the engagement will be much lower, of course, but they have been trained to use the new system and on the advantages provided by the new system. That's it. And then the pilots will be open after the project for technical visits. So probably even at the residential pilot, we'll have some people going there and looking at the system.
I'll also be very quick. So to answer to the second question regarding the what will happen when the project ends. So we are already discussing with the technology providers and users. So there will be, how do you say, we will keep the support. So if the demos, which are mostly residential buildings, will decide to continue having the technologies installed in their houses in the demos, of course, they will receive support. So we are already discussing with technology providers about some kind of agreements on how many years of support they can provide to demos if something happens to the technology. So if they need support, there is this net of, so there is the total intention to continue with the project, so having a life after the project, so they will receive all support. Yes.
Okay, thank you all once more. So it's coffee break time. We are already 5 minutes late. So we have 10 minutes for the coffee break, and then we will be back with the low TRL technology part of the workshop. I would like to thank you, Marco and Serena, and I hope Zabol will be able to join later for the next session.
Okay, yes,
so thank you for interest. With the third session of the workshop, this is, as I said already before, about low TRL technologies and or storage solutions for buildings. Here we have 5 projects represented. 2 of them will be remotely connected, and 3 of them here in presence. Actually, I will be representing the first one, SWS Heating, because unfortunately my colleague Claudia Fabiani, who was expected to be the speaker, was not able to join in the end. So I will be briefly introduce this and then move on with Ministore, and you will see the rest of the projects. So SWS Heating is originally 4 years project. Now, actually, we had to call for an extension, as many of us already did, until the end of next November 2023, which means 5 years and a half overall. It is, as said, a low TRL project dealing with the development of an innovative solution for thermal energy storage for long-term seasonal storage. You can see here at the bottom of this slide the overall concept. Basically, as any seasonal storage technology, the concept is to profit of the high irradiation level during summertime, to store it and make use of it during winter time, mostly for space heating and also to support domestic hot water production. The target, of course, was to develop a new sorbent materials, because the system is based on a thermochemical process, which is involving a salt, basically, which is embedded inside a matrix to enhance the performance, but mainly the stability of the material, and also to develop innovative configuration to reach a much more compact system compared to the state of the art. You can see the consortium is quite wide consortium led by National Technical University of Athens. And we are, of course, I'm showing here. This is more or less the evolution of the project. So, of course, we started from TRL 3 to 4, I would say, working mainly on the material level and on the designing of the components and the KPIs definition during the first 2 years. Let's say by the end of the second year, that was more or less in the COVID outbreak phase, we were able to finalize the definition of the sorbent material, and then we started also to manufacture the amount of sorbent material needed for the demonstration phase. At the same time, we also developed other, let's say, ancillaries or auxiliaries components like small-scale latent storage to support the evaporator of the thermochemical storage during winter time, and of course the solar thermal collectors to charge the storage at high temperature during summer. By the end of the third year, we were able to install the first demonstration plant in our lab in CNR. The tests were partially satisfactory. We just had some issues with the, let's say, the mass transfer resistance inside the bed, but inside the reactor. That's why we decided to change a bit the configuration and also the material way, the way to charge the material inside the reactor. So that's why here we are in the, let's say, ending the fourth year of the project, dealing with the manufacturing of the demo site that will be, let's say, a containerized demo site to be moved around Europe, and to finalize also the large-scale thermochemical storage that will be installed in this demo site. And the last year will be dedicated to the finalization of this containerized demo site that will be then installed in Regensburg and monitored by the OTH in Regensburg, which is the university, Technical University in Regensburg. And then last part of the project will be the validation of the prototype demo in Stockholm by KTH. Briefly, let's say main achievement of the project basically were the development of this new composite material based on lithium chloride as sorbent with achievable energy density up to 1 gigajoule per cubic meter, of course at material level. We designed these new and compact reactors using asymmetric plated exchangers with improved heat transfer properties compared to the state of the art, and many other components of the system were optimized and tested at lab scale. As said, we had, of course, as all development activities at low TRL, we faced some challenges still under, let's say, finalization, like as said, the mass transfer resistance inside the sorber, which was higher than expected, and is now improved by mixing in a different way the material. Validate the long-term operation of the system under realistic boundary conditions. That will be the next challenge we are facing in the last year. And of course, what is really, let's say, the challenge after the end of the project will be how to scale up the process and making it replicable in different operating conditions across Europe. So thank you for the attention, and I think we can skip to the next one, which is the presentation by Minister.
Yes. Can you hear me?
Yes, please. I will switch the slides.
Yeah. So hello, my name is Georgios Gisopoulos. I'm a research associate at the process modeling team of CERF SPERI for the Minister project. CERF is a technical coordinator in the project. So what is Minister? Minister is an innovative, compact, thermal and electrical energy storage system that combines TCM and PCM materials for year-round thermal storage for heating and cooling. It is characterized by a very high energy storage density, over 10 times higher than the density of equivalent water-based systems. It was awarded as part of a Horizon 2020 goal in 2019, and the duration of the project is 54 months, 4.5 years. As you can see on the right, the necessary energy input for the TCM reactor, which is the heart of the system, is provided mainly by PVTs, but also different options were designed and specified within the Minister project for the 5 demo sites that it's going to be demonstrated. The demo sites are across Europe, 2 in Greece, 1 in Spain, and 1 in Hungary, and 1 in Ireland. The first option for the solar field is the combination of glazed PVT collectors, which have a higher efficiency, a higher thermal efficiency, with flat plate collectors. The second is unglazed PVT collectors coupled with heat pump. And the third one sees one of the demo sites is Chimeria, and they're utilizing a lot of RES technology, biomass boiler, and solar thermal field. For the TCM reactor, it contains ammonia and calcium chloride, and during discharging and discharging phases is able to produce heating and cooling power to cover directly the building needs or store it in the PCM vessel for later use. It also includes an electrical energy storage system and an intelligent energy management system for optimized integration of energy storage. The project has been implemented by a consortium of 17 partners from across Europe, and the coordination falls in the National Energy Research Center. During the Sustainable Places conference, me and 4 minister partners will be available for one-to-one meeting. Dries Titiou from CNRS for the TCM and the ammonia cycle, Adriana Coca from ENDEV for the PVT and the solar field different configurations, Paraskevi Dimitriadou from the demo site of Douth, and Marco Rossetti from R2M. Next slide, please. Yeah, so currently the system is in the phase of starting to construct in a container, and a preparatory work for the installation and integration of the system. The system will be first tested in the spring of 2023 in the premises of CERT in Thessaloniki, Greece, and more specifically in the smart home, as you can see in the picture. The smart home is a demonstration platform for mobile technologies. It contains various innovation, smart IoT-based technologies and energy management systems. The testing area will be on the ground floor, and it requires an installation of fan coils in order to connect it to the minister system. Due to the existing solar panels, as you can see on the rooftop of the building, the system will be installed on an open space on the north of the smart home. In the pre-demo side, we have the configuration of glazed PVTs with flat plate collector, and the solar field comprises of 10 PVTs and 5 plate collectors, as you can see in the image. Next slide, please. The Chimeria demo site, it's one of the 4 demo sites, also located in Greece, in northern Greece. It includes a building complex of 11 buildings, and it's mostly student residences. As you can see in the picture, it already utilizes a lot of RES technology, like flat plate collectors, a field, PVS, biomass boiler, and a lot of stuff. So there is no really need for installation of an additional solar field. The testing will be done in 5 student rooms, and again, the integration with the minister systems requires an installation of fan coil units. Of course, for more information regarding the demo site, since Paraskevi Dimitriadou is physically attending Sustainable Places, you can find her at our booth, and he can share you a lot of information. Thank you.
Thank you. We can move on with the next one, which is Solvere by Sodiris.
Yes, hello everybody. Just give me 1 second.
We can hear you properly.
Okay.
Okay.
Thank you very much. So, my name is Karelas. I'm a professor at the National Technical University of Athens, coordinating the Sol BioRev project. In this framework, first of all, I would like to say that it's a pity that I'm not there in this room where you are and in this excellent place where Sustainable Places is organized. So all the greetings to everybody, and I hope next time that we'll be able to drink a French wine together. So this is a project that has to do with the exploitation of renewables, covering heating, cooling, and electricity demand of buildings by integrated innovative technologies. We have 3 goals. We have the development, the integration, the development of innovative technologies systems, the integration by means of advanced control, but also the system validation through pilot testing. We have 2 pilots. I will show you them, one in Greece and one in Germany. And we need to realize the control system as I will present in the next slide, and a future implementation. The consortium consists of 15 partners, and all around Europe, as you can see on the map. So going on to the next slide, I can say that the concept is so is designed for us to cover all the 3 main needs of the building: heating, cooling, and electricity. The sources, the renewable sources are 2. We have the solar thermal, and we also have biomass. But of course, there is a heat pump-based concept, which includes a reversible organic Rankine cycle heat pump. That means that, as you can see in the summer mode, it is possible to produce electricity, space cooling, and hot water by using solar power. In the case in which we also need to produce more cooling, also there is an absorption chiller which will be installed in the pilots. And on the top of that, there is also a thermoelectric tanks, so that can produce electricity. In winter mode, heating is of course more important. So we have space heating, and in the case that we have the absorption chiller is not in operation, and should we need high heating, should we have high heating demands, in this case we have a biomass boiler working with several types of biomass and having very low environmental impact. So going to the next slide, I would like to say that, next slide please. The project faced delays due to the COVID situation, but also due to some problems in the delivery of goods. However, we are well now focused in our pilots. In the first part of the project, we had the potential. We have made calculations to have 100% renewable cooling in Southern Europe, 60% renewables in Northern Europe. For regarding domestic hot water, 100%, and for space heating, 70 to 90%. Regarding the systems development, we have developed the heat pump based, let's say, reversible operation. We have a smart control. This is very important, based on deep learning. Efficient takes operation with solar, and last but not least, a very improved biomass boiler operation of higher than 110 degrees Celsius, which has a notable emission reduction. The system will be tested in Athens and in Nuremberg, in Germany, and it is supposed to start within the next month and to have an annual testing. Going to the next slide, last slide, I would like to show you the Athens pilot building. I'm very happy I heard the voice of Professor Maria Fundi, who is in the audience there. This is the result of a very successful common work of my laboratory together with the laboratory of Maria. And in this building in Athens, we will check for 1 year the systems of Sol BioRev. The whole idea is to go towards zero energy buildings. So we will have, in this building, we have 60 square meters of surface floor area. We have multiple heating cooling systems for system testing at various supply conditions. We have the possibility for testing different envelope materials. This is also presented from other projects of Maria. We will have some artificial loads in order to test different conditions, and we hope that in the next sustainable places we will be able to present the results and to publish in very, very interesting results from this pilot in Athens. A similar pilot, a container type pilot, is about to be installed in Nuremberg, and so that we can test also not only Mediterranean but also Central Northern Europe climate. Finally, last slide. I would like to please go to the last slide. The barriers. The barriers are first of all that we need in the technologies. Heat pump-based system operation under various conditions. We have the limitation of the heat pumps. Regarding techs, the power output is quite low. They are, by the way, installed directly in the vacuum solar collector, and we realize that their power output is quite low. And regarding economic, of course, we have where a low TRL will have high cost of systems and for the integrated system. Challenging also the social acceptance. We have social LCA. We have interesting results also in this area. The main problem is the complexity of the system. So people are, let's say, a little bit skeptical about such installations, and of course, how they will be smoothly integrated in buildings, maintenance, full maintenance, and retrofitting needs. Thank you very much for your attention, and enjoy the rest of the conference.
So, good morning, everyone. I'm Danny Carbonet from SPF, the Institute for Solar Technology. We belong to the university that has recently changed name. Now we are called University of Applied Science of Eastern Switzerland, but our affiliation, or actually our location, is the same as before. I will present 3HP, which stands for 3 generation systems based on heat pumps with natural refrigerants and multiple renewable sources. This is an H2020 project, research and innovation action that was supposed to move the TRL from 3 to 5. It is a 5 million project EU contribution, and it will end up in February next year without delays, well, without extensions, actually. We do have some delays. I was asked to do it in 5 minutes, so I will keep it very, very generic. Tomorrow in the low TRL workshop, I will have a bit more time to present more technology development, and otherwise you can ask me. So basically, what we are aiming at 3HP is to develop systems that are based on electrically driven natural refrigerant heat pumps that are coupled with photovoltaics and that can provide heating, cooling, and electricity. That's why we call them tri-generations. And our target is multifamily residential buildings. The measurable target that we stated at the beginning and that we are achieving is we want to get 80% on-site renewable share, with kind of a net zero energy concept, and 20% of the energy is exchanged with the grid because we are lacking a seasonal storage for electricity or for heating, depends how you look at it. And our main goal from the beginning and how we developed the project was we wanted to have technologies that could reduce costs by 10 to 15% compared to current heat pump technologies that would have the same efficiency. Of course, we cannot compare with an air source, but air source has a way lower efficiency on it. And of course, this will bring a lot of greenhouse gas emission reductions. So, yeah, so we are aiming at 2 kind of systems. One is what we call a dual sourcing system. So here you can see the diagram of it. So our developments are based on the heat pump and on the advanced energy management system. So on the heat pump, in that case, it's a propane heat pump that we developed the refrigerant cycle plus heat exchangers on it. And the innovation of this development is that it has an evaporator and condenser. So the heat pump is reversible. It can provide heating and cooling. And this heat exchanger can exchange heat directly with water for groundwater and with air. And the aim of it is to reduce the borehole length by a factor of 2, which will end up by reducing the system cost by at least 15%. So as I said, this system can provide heating and cooling, and we have an advanced energy management system that it's based on motor predictive control and decides every 15 minutes what would be the next operation optimal decision. And this is also, of course, managing all the electricity, photovoltaics, battery, and household electricity and heating and cooling demands. The second system is what we are calling a solarized slurry system. This system, it's meant to provide heating demands with cooling as an additional add-on. So this is for Central Europe, and it's not meant for like south of Europe. The idea of this concept is, for example, in Switzerland and many other places, we have regulations that restrict the use of boreholes because of groundwater protection laws, and also there is quite resistance to use air source because of low efficiency, noise, and aesthetics. So this system uses solar thermal collectors as a source for the heat pump, but because we don't have enough solar resources in winter or some foggy weeks, and also at night, we use a water storage as a source for the heat pump that is regenerated with solar, with high efficiency, and of course, the heat pump can at some point extract enough energy that's converted into ice. This is a system that exists in Switzerland and Central Europe, and our innovation here was to have an ice storage which is way cheaper, using an ice slurry concept, and we can eliminate completely the heat exchangers on the ice storage. This system is also featuring an advanced energy management system, and it also has this motor predictive control on it. And our development started from materials, isophobic coatings, heat exchangers, up to heat pumps, and we are now testing the complete systems in our laboratories that will bring technologies up to Tier 6. And last but not least, we had the package on technology acceptance. There we were aiming and understanding and improving the stakeholder acceptance and analyze and identify the interests of the stakeholder needs. We had qualitative interviews and also regional stakeholder workshops and in 4 different countries. And the main results of this are published in these 2 deliverables. You cannot see this here, but there is another slide with a better formatting. If not, you can ask me, where I think we can find you can find a lot of good information on this study. And probably this is what we can discuss later on, which is an interesting part. So thank you very much.
Okay. Good morning to all. It's a pleasure to be here. I'm Celina Solari from Rina Consulting, and today I'm going to present this project called RINO, which is an acronym of an augmented intelligence-enabled stimulating framework for deep energy renovation. This project started in June 2020, and it's planned to end in May 2024. And the project aim is to deliver a framework of different solutions in order to accelerate a deep renovation with regard to the energy efficiency of building around all Europe. So to deliver its ambition, the project will offer innovativeness through 3 main pillars. So technologies, in particular, plug-and-play building envelope solution, RES harvesting, multifunctional, hybrid, and storage solution. Secondly, regarding processes, so off-site, but also one-site industrialization and optimization and facilitation. And the third pillar is about business model. So, which are based on crown lending, collaborative financing, crown equity, and also energy performance contracting. And all these will be delivered through a interface with augmented intelligence based on occupant and demo owner-centered approach, which take into account all the life cycle, so from the design, the planning, also the retrofitting, the operationing, and the monitoring. In Reno, there is a consortium of 18 partners. You can see the logo on the bottom of this slide. And it's an industrial-driven consortium, and this guarantee some different advantages, so more facility to involve stakeholder and interaction between industry and also RTOs, and also more interest and interest towards the project result, in particular the marketability, and you can see all the logo. Okay. Today, I'm going to present one of the relevant Reno technologies. It's a innovative storage technology based on a decentralized storage tank for domestic hot water, which is installed in some dwellings in the demo of this project. This decentralized storage tank is done in two design versions, a first conventional wall-mounted version, and then a space-saved wall-integrated version. Then we have also different versions regarding the charging system, so which transfer the energy in the water tank. And so a hydraulic and electric version, but also a third version, and a hybrid one. And we have also some hydraulic components, which are modular and flexible, and they can integrate with a monitoring and control system, which optimize and keep more efficient this storage solution. And this is a technology developed by the Pink partner, so partner of this consortium, you can see here some advantages, some innovative elements of this technology. So from a design point of view, we have a flat shape for a integrated version for low space consumption, and also special heat exchanger design for maintain low network temperature. We have some special materials and components, so new insulation material for tanks, and also with some materials with low maintenance needs. And finally, we have some hydraulic modules, as I mentioned before, and optimized control via bus connected controller. And these elements lead to different advantages for the end user, but for everyone that use this system. So from a cost saving point of view, so regarding a short installation time, also higher efficiency and a reduced maintenance cost, and also a flexibility to have a more integration and a compressive integrated system, and a higher efficiency compared to the conventional system. So this is all from my side. Thank you all.
You sit too. I'm having two roles now. So, okay, so as we did before, we planned some generic question, and again, I really ask you, the attendees, to interact with us as much as possible. So the first point is our challenge is the integration of the technologies that we are all developing, both, let's say, renewable heating and cooling for generation and storage solutions in buildings. So is the, let's say, the technology itself the critical point, or the integration with the already existing technologies, or again, novel technologies, which are the main challenges we are facing? So I will give to them.
So I could start. From the Solarize concept, it is a fairly complex system. So this is installed already in Switzerland and Germany, but it needs experts on it. It cannot be done by just anyone. Then when we did all this analysis on the stakeholder acceptance and barriers, and we also realized, or of course, upfront cost is one issue. This is, I think it's common for everyone. Complexity was another issue, and then lack of expert installers, especially for heat pumps, and especially for heat pumps with natural refrigerant. This is something that is lacking, and that can be a barrier to deploy these kind of technologies.
Okay. Regarding the Reno project, in particular, this specific solution, so the storage solution, and the integration is a relevant issue from two point of view. So from an energetic point of view, so in order to consider all different energy sources present in the building and try to integrate them with this new solution. So the developer, Pink, try to be flexible. And so as I mentioned before, they develop a third variant in order to be able to integrate it with different energy source provided in the different demo, in the different building. But also from a construction point of view, because the solution has to be integrated also in building with different space availability. So they developed this version, a space-saving version that can be integrated directly into a wall, or also between the space between two walls, or inside or between the space or in the space between two doors, for example. And regarding the challenges for a more general level, they have some technical challenges regarding some air entrapped in the system, for example, or some lack of knowledge regarding the installation of this product. But really, I don't know, trust the relationship between the installer and the demo case, because they already know each other. Allow to solve this problem.
Okay, thank you. Maybe I will ask Sotiris for Solvirev, and then we may discuss on the storage side from SWS and Minister point of view.
Yes, I would like to say something which I think is very important. In this panel here and in these presentations, we have low TRL technologies for the integration of renewables in the buildings. Now we have the extremely important challenge to lower the energy prices due to the situation we have at the moment. So low TRL, but very high of integration of renewables. So in my opinion, I think it is out of the question that renewables should be integrated in the buildings. Let's say the way to go to market TRL is should be shorter. So we should all try to have a shorter, let's say, path in order to reach high TRL and go to the market. And the main barrier at the moment is how to do this with no cost. So now there will be, in my opinion, a very big, let's say, debate between maturity cost and how to lower the cost and to be really efficient and let's say environmentally friendly. So I think that it is out of the question that we should go to this direction if we want to reach zero energy buildings, if we want to lower the energy costs in the longer term, but this longer term has come closer.
Okay, we just had some issues with the voice, but I guess we understood more or less the concept. Thank you. So I will just reply to my own question from the SWS team perspective, and then I will leave the floor for the minister. So SWS is about long-term storage, which itself is already challenging, because even if, of course, the concept is sound, is interesting because you can save a lot of energy demand by exploiting renewables from summertime. The fact is that to cover enough demand of a building, you will always need a large-scale storage. Even with thermochemical processes, you still need to have, I don't know, 5-6 cubic meter just to store enough energy to cover, let's say, 40-50% of the energy demand of the building, which of course means that once the technology will be able to reach the market stage, hopefully, probably it won't be available for retrofitting, for being integrated in already existing buildings, just because lack of space for the integration. While of course, in principle, also the integration with the rest of the system of the heating and cooling system is a bit more complicated than a standard solution. But in the end, especially the thermochemical process is like an heat pump, is a long-term storage which is behaving like an heat pump. So in the end, if the system is able to be operated with heat pumps for space heating, especially underfloor heating and cooling, then should be also be able to be integrated easily with the long-term thermochemical storage. Still, the issue is to find the place, and of course, I mean, it's still a technological barrier, which, yeah, it's a TRL 4 to 5, so quite far from the real deployment on the market. What about you, from Minister?
Minister, so since we are a project and that we have to have a year-round thermal storage and cooling and heating, a first challenge was the design and the final configuration of the system, because we had 5 different demo sites across Europe, so different configurations have to be implemented and designed in order to maximize the demands, to cover the demands of the buildings, and also to maximize the operating cycles of the system. Another barrier is that our system uses ammonia, which a lot of research had to be done regarding the regulations, but from our research, mainly impose restrictions to systems with significant ammonia loadings, but nevertheless, the system has to be located outside of the building, at least 2 meters. So if you add also the limited space in the building roofs, or if there is a space in the building roof, it is an unfavorable orientation and slope. This leads to the system being located far from the building. So we are talking about the increasing of the cost in order to have the system efficient. And also from the case of Thessaloniki Kimeri, as I presented, the system could not integrate with the existing system in the demo site, so the installation of fan coil units has to take place. So this adds up to the cost of the system.
Okay, thank you.
Maybe just an add-on on this of complexity and maybe cost and system integration. One thing is, in general, I mean, when you go with an innovative system, of course, the system integration is difficult because there is no one that knows how to integrate this. But I think this is an thing that can be fixed by having enough and proper education. And the other thing is, this is also when, for example, in our case, when we talk about heat pumps, for us, it's clear that heat pumps will be deployed. I mean, all energy strategies of all countries have a large deployment of heat pumps. And if you look at the cost optimum, everything will be air source heat pump, which isn't realistic. I mean, air source heat pumps are very easy, or are easier than ground source heat pumps or the solarized systems, but they have a low efficiency, and especially in winter. And when we are going to lack winter electricity in the coldest months, we cannot afford that all heat pumps are running on air. So we need to pay something of it, and it will be complexity and cost.
I do agree. Marco?
Hi, my question is related to the renovation process, especially to the emission system. So my question is the following. We are all talking about renewable energy systems, which nowadays still struggle to reach higher temperatures. Most of our houses, at least in many European countries, not in all, run on hydronic radiators, which need high temperatures. Where do you guys see the future? Will it be the future renovation? Will be rather high temperature heat pumps working with existing radiators, or will it be, let's say, low temperature, conventional heat pumps, conventional for now, needing a complete refurbishment of the internal emission system by, for example, low temperature heating? This is my big concern, because I acknowledge that sending people out of their homes to reach net zero, nearly zero, whatever energy buildings is a problem. So, and you need to send them out if you need to refurbish to put ground floor. Thank you.
So, may I start?
Yeah.
So in terms of what will be the future, I think we need everything. My feeling is we cannot limit to, there is no one solution for everything. In our case, we have a CO2 heat pump for new buildings that have high efficiency for domestic water applications, especially, and a propane heat pump for more space heating dominated, and then you can go to higher temperatures. Our heat pumps can reach 70 degrees with a proper efficiency. But for example, in terms of if you would change the hydronic system, there is a EU project Plural that Maria is coordinating, and she is doing a workshop tomorrow, or today. And there, for example, one of the systems ideas is to go with a facade, with an hydronic system on the facade, an external facade, so you don't have to get people out of the house to have a low temperature heating distribution system. So I think there are many solutions, and I would say from my point of view, we need everything, because in different cases, different things would be more efficient.
I mean, I agree with Danny. Of course, we cannot solve everything with a single technology. From the seasonal storage point of view, if it comes to the SWS heating project, this is a challenge. I mean, the higher the delivery temperature, the lower the efficiency of the system. So it means that the higher the amount of storage that you need to consider for covering enough space heating demand during the operation in winter. So I would say for that kind of technology, it's mandatory to have low distribution system, low temperature distribution system. There is no chance to go for standard radiators, maybe with the most efficient fan coils technology that are now on the market, but still they are not popular in residential buildings. So I see future for seasonal storage once the cost and the technology will be reduced and the technology will be proven. only in new buildings where they are already designed to use low temperature distribution system from the design phase. So before, that's why I was telling before, in renovation buildings, I don't see the technology having a strong future, let's say. Celina?
Okay. I completely agree also with Daniel and Andrea. I'm not an expert about this the storage topic, so I can give you a precise answer from my side. But I think that keep all the solution and adapt and use it in the different condition and for the different need. It's maybe the best way, and also looking forward new materials for the low temperature solution.
Okay, thank you. I don't know if from Solberg Minister, you want to add something to the question of Marco?
I would like to say that unfortunately, the low temperature radiators, the low temperature provision of the heat is much, let's say, efficient, and all the systems go towards this direction if we want to have more penetration of renewables and higher efficiencies. So there is a bottleneck. It was mentioned that you need to get the people out of their houses in order to renovate these systems. But I will also stick into this plug-and-play renovation solutions that will be presented also in the next presentations. Maybe this could be the solution in order to reach, let's say, the provision of the heat in low temperatures. The rest was answered from Daniel and from Rina and from Andrea, so I think we are all in line with this thing.
Yes, and from my side, I think I agree with most of the speakers. I have to point out that TCM, for example, storage, thermal energy storage, is a state-of-the-art technology. It is capable of reaching high temperatures, but still it's a relative raw TRL. So I think I will answer in more generic that a collaboration with these technologies, heat pump, storage, and renewables, now is the best option, since there is no definitive configuration that fits most of the cases.
Do we have other question from the audience? No. I just wanted to ask once more about the user engagement and stakeholder involvement. I saw you did a lot of work in 3HP, and it would be nice to have a look to your deliverables, but if you can give some more details, briefly, which kind of questions were issued to the stakeholders, and which are the feedbacks you received?
So how it was organized, this was organized by ISOE, an Institute of Social Research in Germany, and they started to do first interviews. So in 4 countries, we selected key stakeholders that would represent different stakeholder groups, and they had interviews. At that time was COVID, so they had to do it online, which actually was not that bad from their point of view because they could access to more people. And from this result, they analyzed, and then they prepare workshops where we had, again, the same people on different countries, and then topics were discussed on very specific things. And of course, there the main things were use of heat pumps and the storages and solar technology. That was the main 3 things. And as I quickly said before, on heat pumps, of course, we have a very different readiness level or social market or market penetration in different countries. In Switzerland, for example, heat pumps are standard. They are used everywhere. South Spain, South Europe is not that common. So then we had to differentiate this. But what was common was that people is lacking experts on, it's lacking installers. This was a very common and repetitive thing across Europe. And especially, again, when you go to natural refrigerants, there is very little experts that can really have this kind of heat pumps. And I mean, CO2, it's a high pressure thing, and propane, it's flammable. So you need to know how to handle these things. And this was the main thing that was common. Of course, the other things are more typical, like upfront from cost. It's also, and then in some places it's lack of awareness, but this is again very country dependent.
Regarding the Reno project, for what concerns the interaction with the end user, the project tried to develop a platform based on an occupant approach, and so there is a Reno suite that try to collect all end user feedback and the feedback from the demo owner, and so they can interact and also give them some suggestion and rule. And beside of this, this platform from a more design point of view can suggest to the end user some optimizing scenario, also based on the end user priorities and feedback collected before. So there is this interaction.
Thank you, Celina. So there is wants to say something about the
regarding the engagement of the people. As I said before, sometimes the technologies are getting a little bit more complicated, and this maybe frightens a little bit the users. So this was also within this social LCA, and we tried to find out what is the opinion of the people there. So they are frightened, but they are also willing to learn how to use the new technologies if the result is lower energy cost. This is one thing. And the second thing that I would like to say is that due to the issue that we have deep learning, smart control with deep learning, this gives an added value to the whole, let's say, concept. And therefore, we're trying to have the user feeling as comfortable as possible without interrupting the system. So this deep learning, I think, is one good solution for the smart controlling of the systems.
Thank you.
From the minister side, for the Thessaloniki pre-pilot and the DUTH, since they are a research center and a university campus, there was not, and particular the Demosaphicum area utilizes a lot of these technologies, so there was not such a problem. Nevertheless, at least DUTH team prepared questionnaires which informed the students about the benefits or the potential dangers of the system, since it uses ammonia, but since they use the system is positioned outdoors, it ranks as a low risk. Nevertheless, I think a lot of work has to be done regarding improving the confidence of the end users to the system and to renewable energies.
Okay, just one last comment from my side, then we need to move to the last session. On this regard, we did something similar to you. So University of Sussex was in charge for doing the interviews, and we got interesting results that are also in public available, so you can have a look at them. What was interesting, what actually not planned in the project and the proposal, but what the University of Perugia did also was to select a large number of keywords related to renewable heating and cooling solutions, stuff like that. and they did this deep, I don't know, research on website, on radio, TV programs, whatever, to understand how many times these keywords were mentioned, to understand how much thermal energy storage or heat storage was on spot, and they discover it's almost unknown. So no one is discussing about thermal energy storage in, let's say, on the public, not on the scientific side, but on the public side, and which means that it is not recognized as a critical task. So technology-wise, PV or wind were the most popular words used, or in general renewables, or even batteries. But thermal energy storage was barely never mentioned. So this is also a proof that I think they just published now a paper, a scientific paper about this. This is a proof that also from this side we need to, demonstrate or show that these technologies exist, and that in the end is relevant for the future application. Not necessarily the seasonal storage application, is also the short-term thermal energy storage that is completely unknown from the people. Just to finalize this, so I would like again to thank you all for attending, and we'll now move to the next one about renewable heating and cooling for nearly zero energy meetings.
Thank you very much. Bye-bye from us.
Thank you.
I think plural is the first one. Can you switch on to the presentation? Maybe I can. No, cannot. We need to keep the time, as I said, because the organizer are asking to keep. We have 20 minutes, so I think it's enough. And I remind you all that we have the envelopes with the brochure and leaflets of the projects. Please remember to take one for you. Regis or someone from the technical room, can you switch to the presentation mode?
Can I change the slides? Is there a laser pointer?
No.
Okay.
Okay, please.
Okay, so good morning to everybody. My name is Maria Funti, and I'm the coordinator of the Plural project, which stands for Plug and Use Renovation with Adaptable Lightweight Systems. We are at the end of the second year of the project. We are 18 partners from 5 countries, and the aim of the project is to develop what we call hybrid plug and use kits. Plug and use is a paraphrase of plug and play, because we take into account building user requirements. And these plug and use kits, or PNU kits as we call them in short, they combine active with passive systems and technologies. They are adaptable envelope systems, hybrid systems, and they combine the recent knowledge from previous or other EU projects, like, for instance, the SolPREV, or the project that Danica Bernal just presented, to integrate these renewable energy technologies with prefabricated envelope systems. In the Plural project, we developed 3 different types of PNU kits. The first one is called Smart Wall. You see it on the top. It's a system that combines very well insulated envelope component with fan coil driven by a heat pump and powered by a PV system. It includes integrated in the prefabrication the control system, as well as all the monitoring system, both of the component or the kit itself, as well as the interaction with the building. The system is currently demonstrated at the Living Lab that was presented as part of this Sol BioRev by Professor Karellas. The smart wall comes in different forms, as you can see in the picture, with window, without window, plain wall, and it is designed to fit the exact requirements of the demonstration building or of the building where it will be applied. It can be an internal or external application, and it is targeting buildings that are poorly insulated, aiming to reach the NZEB status. The second system that it is developed in the frame of the Plural project is called hybrid wall. It is based on a pre-existing technology of our Spanish partner Envelopes, which is a folding facade. You can see a visual representation on the side, and it is extended to include an air handling unit developed by the CDUT in the Czech Republic, as well as driven also by PV system, integrated either, as I said, I forgot to say this, on the facade of the PNU kit or on the roof of the building. Again, the system, the kit includes the control system, and it can be placed as an add-on to external facades that are also poorly renovated. The last but not least system that we are developing, it's a hydronic wall system that it is targeting mainly cold climates. It is a technology previously developed by SPF, OST, and it is it has already been demonstrated here in the project. We go a step further, and we integrate it in prefabricated wood panels. The system is also driven by a heat pump, which is powered by PV systems. Via this short I forgot also to say that all these three kits are supported by smart windows with mechanical ventilation and heat recovery, as well as control systems that we call them toolboxes that are integrated in the prefabricated kits and monitor both the performance of the kit, taking data from the buildings where they're going to be installed. It is clear that this type of plug-and-use kits should be designed to meet, first of all, the specific building requirements, but also, if we want to reach NZ status, to meet the requirements of the local climatic conditions. So our demonstration, here you see an overview of the smart windows that I told you before, the toolboxes, and the supervisory control system. The data that we collect from the monitoring of the buildings, as well as the performance monitoring of the PNU kits, are stored in a cloud platform, a commercial cloud platform, previously developed by our partner Intrasoft. So I was saying that it is a prerequisite to match the design and the prefabrication of these systems to the building characteristics. We have three real demonstration sites. One is in Greece. It is the one on the left that you see on your slide, where we will implement a smart wall. It's a Mediterranean climate with hot summers, and we will be able to cover both heating and cooling needs. The second demonstration site is in Terrassa, in the vicinity of Barcelona. It's the middle one, where we will implement the hybrid wall, and the third one, as one could expect, is in the Czech Republic, in a small city called Kasova, where we will implement the EWHC system, the hydronic external wall system developed by OST. To further validate the performance of these buildings, we have what we call three virtual sites. One is in Sveby in Sweden, where we will implement the EWHC system. The second one is in Berlin, where we will extend the application of smart wall in the Nordic climate. And the last one is in, in Bern, where we will also implement virtually the EWHC system. The project also deals, of course, with the validation of the environmental performance and the financial viability of these PNU kits, ensuring that we can reach the NZEP status. And the target is to reach 50% reduction in the renovation time, and up to 50% reduction in the renovation costs. A lot of effort is put in the manufacturing of these prefabricated PNU kits that are also tested, and this is just to highlight how much more complicated it is than developing a simple renewable energy system. These systems have to be tested also for the static performance, dynamic performance, apart from thermal performance, acoustic performance, and fire performance. So it is an interactive process, design, targeting the specific building, using BIM technologies, integrating in the BIM mentality all the active systems plus the passive systems, validating, manufacturing, and going back prefabricated, totally prefabricated to the real demo site. So, bottlenecks, criticisms. A lot of the things that have been discussed today apply to us as well. For instance, user interaction. How do we get permits from the users to install this kind of prefabricated systems? They can be installed very fast. From the demo, from the pilot demonstration that we have in Greece at the moment, we had with the smart wall of AMS 10 minutes for the installation of the entire system, which is an exceptionally fast installation. But still, you have to get permits from the users to install this kind of systems. They should be part of all the monitoring procedure. The post-project maintenance and validation is also a problem for us. And currently, these are three hurdles that we have. First of all, the increase in the energy and diesel prices affect production capacities and increase the production costs. So it is very difficult to reach a target of reducing the overall prefabrication cost, including both passive and active systems due to the current situation. Shortages in raw materials, which make it very difficult for the manufacturers to incorporate especially the renewable energy systems in their prefabrication process. And the current global situation affects business and delays a lot of development of new business models that are necessary to permit the introduction in the market of this kind of prefabricated plug-and-play systems. So thank you very much for your attention, and I hope to give you a good overview of what we're doing.
Good morning again. Now I will present the Envision project, energy harvesting by invisible solar integration in building skin. This project started 5 years ago, and it will end now in this month. In fact, in this day, there will be the final general assembly. This project has developed a renovation concept that harvests solar energy from all the building surfaces, so vertical, horizontal, but also transparent and opaque. And it has contributed to the European vision and also to the greenhouse gas reduction. And This project focus on the solar energy harvesting from thermal and electrical point of view, and it has been possible thanks to some hybrid solution installed on the facade, in particular some coatings, colored coating with a particular coating that exploit also the solar energy in the invisible part, so in the near infrared, which is about the 50% of the solar energy spectrum. In the consortium, there are the partners that you see in the bottom of this page, so 8-9 partners that contribute to this project. In particular, today, I will give you an overview of 2 innovative solutions. The first, a facade solar collector with near absorbing colored coating, as I mentioned before, and then a smart ventilated window. So the smart ventilated window is a solution that was developed by Bigitech and was installed in an Italian educational building in Liguria, in Savona, which is considered the south demo case in this project. This is a triple glaze window that harvests the solar radiation for a double purpose, so for space heating, but also for domestic hot water purpose. So it is enabled to use also the glaze surface for energy production, maintain the aesthetic aspect, so the air transparency. And this solution contributes to optimize heating and cooling loads in all the seasons, so in winter, but also in summer, because this solution can switch into different mode thanks to a control system. And this smart ventilated window can contribute to optimize the building energy consumption from a double point of view. So from the reduction of building energy demand, and also produce thermal energy thanks to the solar energy accumulated in the window itself. The second solution is the facade solar collector with near absorbing colored coatings. It is developed by TNO together with AkzoNobel and Emergo, so 3 partners together. And it is installed in 2 demo cases, so in the Netherlands demo case, so the north demo case, and also in the Savona campus, so again in the Italian demo case. This system includes some solar thermal collector installed on the facade of the buildings, and as I mentioned before, they are produced with the particular coatings that make possible exploit the solar radiation also in the invisible part of the solar spectrum, so the near infrared area. And the solution, it has been linked to the grid and network already present in the Savona campus, and it is demonstrated and tested. So this is all from my side, from these two solutions.
Yeah, we only have a few minutes to discuss. So one of the points that we mentioned is which are, in your opinion, the most relevant renewable heating and cooling solutions to be applied in order to reach the status of nearly zero energy buildings, if any. I mean, if you see, for example, heat pumps or anything else that can be widely deployed to reach that status.
Do you want me to start?
Sorry?
No, it's okay. Okay.
I think that it's the best thing is to have a combination of a different solution. Regarding the envision project, in particular the smart ventilated window can positively affect the energy performance of the building and create an energy positive building, in the sense that it could operate in all the during all the years, or in the summer, but also in the winter, because thanks to some grid and some fan and the control system, this solution can switch into different modes. So we have a better energy efficiency in winter, because this window can accumulate heat inside, and then through this fan fed it into the room, and so contribute to the space heating, and also in the summer, because thanks to some grid can transfer this heat accumulated inside to a heat exchanger, and so contribute to the domestic heat water. So there is a contribution towards a zero energy building from this point of view. And so a combination of all these solutions, smart window, the facades, also photovoltaic for PVC for the roof, can contribute to this. Thank you.
Okay. If we talk about prefabricated hybrid systems, obviously what you want to do is you want to exploit the surface of the prefabricated kit, that it is exposed to sun. So your renewable energy source must be sun-based. In the future, probably wind-based with small wind turbines. The challenge here is to have enough area to cover, to produce via PVs or solar thermal systems the energy that it is needed for the heating or the cooling of the space that you want to install, which is a challenge at the moment, because the efficiency of the currently available PV systems is not that high. Challenges for the future are, of course, integration of OPVs or of other smart technologies at the windows, at the transparent parts of these prefabricated PNU kits. And one of the problems that exists at the moment is the scaling of the commercial systems, heat pumps, for instance, or even if I go further to Stirling engines or something that could be incorporated in such a kit. Generally, commercial systems are dimensioned to cover more than a specific space, apartment level or building level. So proper dimensioning of the energy production system to cover the requirements of a small room or of a specific room, it's a challenge, because what you want to do with all this prefabrication is not to overscale or over-dimensionalize your energy system. You want to keep it to the minimum scaling in order to exploit storage capacities to reduce the energy consumption. So it's a concept like the one you once, for instance, could use at the district level, where you produce small amounts of energy via a prefabricated kit. You store this energy via a central storage system, and then you distribute it to your consumers depending on the requirements. So over-dimensioning, oversizing, matching the size of the energy production system to the space requirements is a challenge. And of course, the control systems. In this type of renovation or production of prefabricated systems, you have to match the energy source, i.e. PV, solar thermal, combination of them, wind probably, with the local operation of your heat pump, fan coil, or air handling unit, energy recovery unit, with the building overall monitoring. And these are the commercial systems that exist at the moment. They are not, their control systems are not open to modify them. And the coupling of different systems is, I think, a common problem that exists to all the projects. Because each manufacturer, each producer has its own philosophy of developing, its own protocols, and matching them and mixing them together, it takes time and effort.
Thank you. So we are a bit late already. RHC is asking for closing. So thank you again. And if you have any other question, we'll have time. Yeah. You need to bring with you the bags because they are not closing the doors, I guess. And yeah, thank you again. And thank you all for attending to this workshop.
And let's hope for the fourth one.
Yeah.
Next year.
Let's